Yeah, hello all. In this video, we are going to see the third part of the linked list code, that is insert at the end. Okay, so let me remind it again. To understand this particular code, you need the knowledge of structures in C as well as arrow operator, how to implement the arrow operator in the structure in C. Okay, so before overall watching the videos, this video, okay, I will attach the previous two parts in the description. Okay, and then as well as this is the last part of the insertion. I am not going to demonstrate you on deletion. Okay, so if you are understanding the insertion, now in this particular video description, I am going to share you that particular whole code of the linked list what I have implemented. In that particular code, deletion also there. Okay, so if you are very clear about how to insert the data logic works, okay, you just make it the picturization like this, how to delete it. Okay, how to delete the node. Okay, so likewise you can do it by your own. Why? Because linked list will be the very important logic. Okay, we have to study how to store the unlimited number of data linking with each other, in which we can traverse with the particular next address reference. This is the very successful linear data structure which will be we are implementing mostly in all the real-time applications. Okay, so I request all first understand the insertions and try to understand the deletion logic, which I have attached the whole code with these descriptions in this video, in the video descriptions. Okay, you can view all the details in the video descriptions. Let me go to the code. Okay, so first of all, insert at the end. So this is my overall data, sample data. That means assume that I am having already three datas. I am going to insert at the last node. Okay, I am going to insert my element as a last node. Okay, for that, this is my particular code. I am going to, this is the particular code. As I already told you, don't see the code as a whole bunch of instructions. Decode the code one by one. Okay, so just like a mathematical logic, substitute that. For example, first I am going to allocate the memory. Okay, using the malloc, I am going to just name it as a new node. Next, I am going to pass my data. That means I am going to pass my data and I am going to store into the new node and my new node of next. That means I am going to assign my next as a null. That means like this. Okay, here example, I am going to make it my 45 as a new node. Okay, and then new node of data and the null I am assigning as a null. So my address of my particular new node is 1007. These are all the assumptions 1007, 1002, 1003 based upon the hardware architecture or based upon the storage architecture. Our particular address representation will differ. For our logical understanding purpose, we are just naming as 1007 like that. Okay. So coming to the point, this is my new node. Then what I have to do means first I am checking whether head is null or not. First I am checking whether the linked list is already created or not. Okay. So if it is not created means head is a null. Okay, so in the previous video, I told that when there is no element in the linked list, null will be the head. Okay, so I am checking whether the linked list is there or not. If it is there, my new node is a head. That means one and only data is 45. Okay, but in our case, it is not like that. Already we are having three datas. Okay, so my condition is false. Already we are having three datas in our linked list. Our condition is false. So we have to move over to the else part. In that else part, I am going to just assign my head as temp. Okay, so here I don't want to just repeat my head variable to traverse throughout my linked list. So I am renaming temporarily my head variable as temp variable. Okay, so just for my traversing purpose. So what I have to do means here I am going to traverse up to when my particular temp of next is not equal to null. It will going to check my temp of next is not equal to null. Okay, that means when the temp of next is equal to null, my while loop stops. My temp pointer is stop in that place, correct? So I am going to travel. First, my head is a temp. Okay, temp of next not equal to null. 1001 it is there. It is not equal to null. So temp equal to temp of next. Condition is true. So temp equal to temp of next. Now my temp will be 1001. Now the 1001 of next temp of next is not equal to null. Yes, condition is true. Now it will going to move over to the particular next node. Now my temp of next is not equal to null. Now my condition is false because my temp of next is double equal to null. So my condition is false. Obviously what I have to do means where is my temp? My temp is in the last node. Now what I have to do means I am going to assign my new node as a temp of next. In the temp of next address storage, I am going to assign the new node address. So let me remind you what is the new node for us? 45. Okay, the address will be 1007. Obviously, I am going to attach my particular temp of next address value as 1007. Then it will be connected. My 45 is connected to the last. My 45 is a though 45 is a last node. The automatically the last node will be assigned. The last node of next is assigned as null. Okay, in this way, insert at the end works. Okay, so this is the last part of the linked list of singly linked list. Okay, so the deletion logic is there. If you understand the insertion logic, I will attach the whole code of the this particular implementation, whole bunch of code. Combinedly, I will attach in within the descriptions. You can just execute the deletion also. You can try to decode the deletion by yourself. Then you can understand the linked list, singly linked list clearly. Okay, this is the very basic explanation of three sample code. That means in the video 1, I have explained about the insert at the beginning, and the video 2, insert after the position. This is the last video part, insert after the end. All the details, remaining videos and the codes you have seen in the particular description, you can view it. Thank you.